Hello, algebra students. We're going to be looking at proportional relationships. So you want your proportional relationships worksheet 1 packet. And we just have a couple of notes about proportional relationship. You may have looked at this type of relationship last year when you were dealing with proportions. They are very related. So we'll just look at this kind of from an algebra point of view. And so we have proportional relationships, and that means that the relationship varies directly. So sometimes you'll hear this referred to as a direct variation. It means that the slope is constant, or the unit rate. So that slope is constant. And you should know that that slope is referred to also as your unit rate, and that's really how you would have dealt with it last year with proportions, as a unit rate. And so because it is the unit rate, it is also sometimes referred to as the rate of change. And proportional relationships have an equation form, and that is y is equal to mx, where m is the slope, which you have looked at before. So we have this first situation where Alex spent the summer helping out his family business. He's hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. So Alex wonders, if I can continue to work and can earn the money at this rate, so that same rate, that's that rate of change or slope, will I have enough money to buy the gaming system at the end of the summer? And so we want to look at that. So we're going to take a look at the questions in relationship to that. So we want to look at how much Alex gets paid per week. And so this is the relationship that we're looking at. So we're looking at how much he gets paid. So that's money per week. So that's the relationship we are looking at. If we were considering this as an input-output table, like you looked at the other day, then your weeks would be your X and your earnings total would be Y. And so we want to take a look at what we have in our situation is that he has $112, and that goes with 4 weeks. Now we want to make that into a per week, so we want to look at that being a unit rate, which means we can either divide by the denominator there, or we can just, you would just do the division to find that unit rate. So we want to know per week or for 1 week. And so you want to work that out, enter that into your Edpuzzle. And you should have gotten that it was $28 per week. And so, if he works nothing at all, he's of course not going to make any money. But if he works 1 week, he gets $28. Then you want to fill in the rest of them to do part B. Will Alex have enough money to buy a new gaming system by the end of the summer? Complete the table to show your work. So you could go through and just kind of do the end product, but let's go through the process. So 2 weeks at $28 per week would be $56. 3 weeks would be $84. Go ahead and complete that, and then tell me what it would be for 5, 6, 7, and 8 weeks. So you should have that recorded, and you see that he has $224 by the end of week 8. And so then, will Alex have enough money to buy the new gaming system by the end of the summer? Yes, he would, because he would have $224. So yes, he has enough, or would have enough at the end of the summer. So part C asks, are Alex's total earnings proportional to the number of weeks he worked? How do you know? And basically you're looking at that in a few different ways. You need to look that the rate of change remains the same. So that is that per week, or that $28 per week. So this is yes, because the rate of change remains the same. To write the equation to illustrate the relationship, we need to kind of think about what that equation is. So previously we mentioned that your equation would be y equals mx, but let's take a look at that in this situation. That your weekly earnings would be equal to the rate of change, or your unit rate, or rate per week, times the number of weeks. And in our equation, that earnings, it would be our y, we said that would be the output. The rate is $28 per week, and then the number of weeks would be x. So your equation is equal to y equals 28x. For the next situation, we have John filling a bathtub that's 18 inches deep. He notices that it takes 2 minutes to fill the tub with 3 inches of water. So that's our first kind of mention of a relationship or rate. 2 minutes for 3 inches of water. He estimates it will take 10 more minutes for the water to reach the top of the tub if it continues at the same rate. Is he correct? And we want to explain that. So we want to look at what we're comparing. What is the relationship we're looking at? We're looking at the minutes it takes to fill the inches of water, or inches per minute. And so it takes 2 minutes, and that fills 3 inches. And then if it's proportional, okay, if it is continuing at the same rate, this is where you want to think about what you did last year, then you can make a proportion with that. So proportion is 2 equal ratios. So that means that he's estimating it will take 10 more minutes. So 10 plus the 2 that already passed would be 12 minutes. And the idea would be that it would fill to the top of the tub, and that's 18 inches. So we're questioning whether or not that would be equal. And so you really want to look at comparing that. Now there's a couple different ways you can compare that. You could change those values to a decimal and see if they're equal. You can also recall the fact that your cross products should be equal, so you can compare cross products. You could see if they're equivalent fractions by seeing if there's a multiplier by the denominator that you could also multiply by the numerator. So looking at any of those 3 ways to compare, are those ratios, those fractions, equivalent? And the fact is that they are. So this is, yes, this is proportional. Yes, it would continue at that same rate. And that is the rate of change remains the same. So a new self-serve frozen yogurt store opened this summer. It sells yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. So each member of Isabel's family weighed their dish, and this is what they found. So you have the weight in ounces and the cost. And if we would look at that, your weight in ounces as an input-output table, that your weight in ounces for the yogurt would be X, and the cost would be Y. So we want to know if the cost is proportional to the weight. So we want to look at that rate of change. Now, one of the ways that I'll do that is just to do the division and just say, okay, let me take my X and divide by my Y, or you could do it the other way around, but whatever you want to do, you want to keep it consistent. So I'm looking at here at doing 12.5 divided by 5, and that gives me 2.5. This doesn't stand for anything particular right now, but we're just seeing if it's the same. So then I do 10 divided by 4. It also gives me 2.5. I want to make sure that that's consistent because a proportional relationship will have that continued rate of change. So I would do 5 divided by 2, also 2.5, and 8 divided by 3.2, also 2.5. So I find that that's the same the whole way through, then that is telling me that it is proportional. So I can say yes, the rate of change remains the same. And then we're asked to graph that relationship. You're probably doing some of this stuff, or you already have been doing this graphing in science class. We have our x-axis going along the horizontal, and your x-axis is going to represent our weight in ounces. And I'm just going to make that 5, 10, 15, and 20 ounces. And then our y value is going to be our cost. So on our vertical axis is our y. And that is going to be our cost in dollars. And I'm going to, I think I'll do that in 20-cent increments. So that'll give me like 20, 40, 60, 80, and that would be $1. And then 20, 40, 60, 80, $2. So we're going to establish that scale. Pause and establish the scale if you need to. Okay, so we're going to graph. You should be able to take your graph up a little higher, up to like $5 or a little more. And we'll cut off here for space. So we want to finish graphing. So we're going to graph our ordered pairs. I'm going to graph the ones that fit here. So at 5 ounces, the cost was $2. So where I'm looking at 5 ounces on the across, then I'm going to go up to $2, and that would be my first ordered pair. Now I'm showing the movement there with the highlighter. You don't have to draw that in. That's just me referencing where I'm graphing. And then, we have the 12.5 ounces. So that would be, I've got 10, 11, 12, and 13 would be, so halfway between 12 and 13. And then that would be up at $5. Now that on my graph is going to go, because my scale is off here, a little cut off, is that's going to go up a little higher here. But you can graph that on yours. And for the 10 ounces, so I could go across here. To 10 ounces, and that was going to be up at $4, so I can graph that one on my graph, and that would be $4. Because this is a proportional relationship, those values will create a line there, so I'm just going to draw a line to connect those. And then we look at use the relationship to predict the total weight you can buy for $7. So we can use the unit rate, and the unit rate is that if it is if you get 12.5 ounces for $5, then we want to look at that unit rate. Now, if we're looking at, the cost for $7, we can take a look at that relationship as the weight compared to the cost, or we can take a look at it as the cost compared to the weight, either way. And when we're looking at that, then we want to take one of the values that we've been given. And so, for example, we have a cost of $4 going with a weight of 10 ounces. And so we would want to change that into a unit rate. And so per ounce cost there. And that would give us 0.4. And so we want to really look at that relationship in terms of for $7. And we could do that with a proportion. So one way to do that is to kind of go back, and you can either take your unit rate or the previous relationship and say, okay, if the cost is $7, then what is the weight that I can buy that way? And you can solve that as a proportion. Again, this is a proportional relationship, so that goes back to those skills that you learned in 7th grade to cross multiply. And multiply and then divide. I'll just move over here. And so we hopefully find that we can get 17.5 ounces for $7. So in sample 4, we've got Kayla making observations about selling the price of a new brand of coffee that's sold in 3 different size bags, and she recorded those observations in the table. So we have the ounces of coffee compared to the price in dollars. Now again, to see if it's proportional, I'm just going to compare them in a consistent way. So I'll just typically do top divided by bottom. You could also do bottom divided by top, or see if there's a consistent multiplier, etc. So I would, look at 6 divided by $2.10. But in this case, I'm going to flip that upside down and think about it in terms of cost per ounce. So I'm going to take 210 and divide it by 6, and that's going to give me 35 cents per ounce. Then I look at the next relationships and say, okay, $2.80 for 8 ounces of coffee. $2.80 divided by 8 would be 35 cents per ounce. Okay, looking good so far, same rate of change. Then I look at the next one, $5.60 for 16 ounces. So $5.60 divided by 16 is the cost per ounce. And again, 35 cents per ounce. So that is proportional. So yes, this is proportional because the rate remains the same. And then we can use that relationship to predict the cost of a 20-ounce bag of coffee. So again, it's looking proportional. So I'm just going to take that first relationship of, okay, 6 ounces and comparing it to the cost, 6 ounces for $2.10. And, what is that equal to? I'm looking for 20 ounces, and so that is my unknown, is what is the cost for that, 20 ounces. And I can use proportions to solve that. So if I cross multiply, I get 6x is equal to, and then I'm going to take a look at 20 times 210, and that's going to give me 42. And then I've got to divide both sides by 6, and I get x is equal to 7. So using that relationship, I find out that it would be $7 for the 20-ounce bag of coffee. So in example 5, we have the table below shows the relationship between the number of cars sold and the amount of money earned by the car salesperson. And we want to know if the amount of money earned in dollars is that proportional to the number of cars sold. I'm going to explain why. Now, if we were looking at an input-output table, then the number of cars sold would be X and the money earned would be Y. And we have what would be our unit rate there is that you get $250 per car if it's a regular rate. Now, what you want to look at is, does that stay consistent? If it's $250 per car for 2 cars, giving you $600, is that rate the same? Well, that doesn't really make sense, because if it were $250 for each car, if they sold and the rate were proportional, if the rate were the same, then 2 cars would give you $500, not $600. So the answer to this is no, it is not proportional, because the rate of change is not constant. All right, remember to take your questions into your algebra teacher, and we'll catch you next on Proportional Reasoning Part 2.